Hello students, welcome to Unit 9 Notes, Section 10-2. You can pause the video at this time if you'd like to complete the warm-up. Notice that I broke the trapezoid up here into rectangles and triangles like it asked me to. In this lesson you'll learn how to actually find the area of a trapezoid, but for now you can follow along with this. All right, so today we're doing section 10.2, areas of trapezoids, rhombuses, and kites. Rhombuses and kites follow the same formula. Trapezoids have a different one, and we'll go over those. So the area of a rhombus or a kite is quite simple. It is 1/2 of the diameter 1 times diameter 2. And if you think about the way a rectangle works, think about a rectangle or a square. That's not a good. Let's try this. Why is it not undoing? Huh, that's weird. Oh, it froze. Hold on. Let's try this again. So, there we go. Okay. If we were to create a rectangle, this isn't going to be perfect, but I will try my best. If we have a rectangle, rectangle is base times height. So imagine that this part right here is your base, put it right down there. This part is your height, you can put it right here. So base times height. Well, why is it 1/2 base times height? Well, because these are the triangles that matter, and these are the triangles that don't. So really, it's no different than base times height, other than it's only half of it. It's half of the base, half of the height, which ends up being 1/2 diagonal 1 times diagonal 2. So that is the equation that you'll be using for the rhombus or a kite. And then for the area of a trapezoid, this is a formula they give you. And I do not like at all the textbook's formula because it seems confusing. 1/2 of the height times base 1 plus base 2. So what it's saying is it's 1/2 of the height and then 1/2 of the height and then b1 plus b2. Well, I think what they mean to say, and we're going to correct it, is why don't we average b1 and b2 so that one is shorter, one is longer. But if we average them, when we do, we kind of come to halfway on that triangle, come halfway to that triangle. And if you average b1 plus b2, you get your base. You get your actual length of one of your bases. And then you multiply that by your height, h. So it's taking this part of the triangle and putting it there, taking that part of the triangle and putting it there, and it's really averaging your base. So I don't like to write it that way. I actually like to write it this way. I like to write it as area equals the average of my bases times my height. Again, you can use any formula that is equivalent, but this one makes more sense to me, other than finding half of my height and then multiplying that by base 1 plus base 2. Yeah, so let's go to the next. So now that we have our formulas, let's actually do example 1. Approximate the area of Arkansas by finding the area of the trapezoid shown. So it looks like base 1 and base 2 are given, 250 miles and 190 miles, with a height of 242 miles. So area here, area is going to be b1 plus b2 over 2 times my height. So area equals 250 plus 190. So 250 plus 190 miles over 2 times height, which actually, you know what, I'll put height in, which is 242 miles. 242. So let me get my calculator. So we have area equals 440 miles divided by 2 times 242 miles. So we have area equals half of 440 is 220. You know what? I wrote really large, so let me move this over. 220 miles times 242 miles. So divided by 2 times 242. So it's going to be 53,240 miles. That seems like a lot, but we're talking entire state. So yeah, square miles. Oh, sorry, square miles. I said it, but I didn't write it. So it's about 53,240 square miles. Obviously not perfect, but we can approximate that. Okay, find the area of a trapezoid with a height of 7 and bases 12 and 15. So I'm going to write a little bit smaller now. I have area equals B1 plus B2 over 2 times my height. So area equals 12 and 15 over 2 times height, which is 7. So 12 and 15 is 27. So we have 27 centimeters over 2 times 7 centimeters. And that's going to be 13 and a half times 7 centimeters. And you could have done this all in one step. You didn't have to write 2. But we have the area is equal to 94.5 centimeters squared. All right. The next one, we have a finding area using a right triangle. So we have a special right triangle. We have a 30, 60, 90. This trapezoid, the trapezoid has a special right triangle. So what we're going to do is we are going to break this up into a 30, 60, 90. We're going to put 30, let me zoom in. We're going to put 30 degrees. Let me clean that up. 30 degrees right there. Let's change the color so it's easier to see. Okay, so now if you notice that this is a length of 5, this is a length of 7. So let's get rid of 7. Let's break 7 into 5 and 2. So right here we have 2 centimeters, and I'm going to get rid of this and make this one 5 centimeters. It doesn't really matter. I guess I could leave this whole thing 7 because I'm going to need that later on when I'm finding the area of the entire trapezoid. But for right now, We're going to leave it like that. So it's a 30, 60, 90. So in a 30, 60, 90, remember in a 30, in a 30, 60, 90, we have H equals S times 2. We have L equals S times the square root of 3. Remember, the hypotenuse is equal to double the short leg. The long leg is equal to the short leg times the square root of 3. So it's all about the short leg. So in this case, when I look at what I have, it appears that I actually do have the short leg because it's opposite the 30-degree angle. So the short leg is 2. I'm going to put in all of my values here. I'll say H equals 2 times 2. So H equals, and we're talking centimeters, right? Centimeters? Whoa, we are talking meters. How could I mess that up? Let me fix that. Two meters, 5 meters, 7 meters. I'm going to go back over here. We get 2 times 2 is 4 meters because it was 2 times 2 meters. So we have 4 meters, and then we have L, which is 2 meters times the square root of 3, which is 2 square root of 3 meters. And the thing is that this right here is going to be 2 square root of 3 meters. The hypotenuse, which is opposite the right angle, will be 4 meters. We don't need to worry about either of those because it looks like we have 2 square root of 3 meters, and that's what we needed. We needed the height. We don't need the 4. Really, I did some extra work that I didn't need to do. So I have area is base 1 plus base 2 over 2 times height. So we get 5 plus 7 over 2 times the height, which is 2 square root of 3 meters. So we have area equals 12 over 2 times 2 square roots of 3. So area equals 6 times 2 square roots of 3. So area equals 12 square root, 12 square roots of 3 meters. And, meters squared, because it's meters times meters. And it appears that that is one of the answers. There we are. So it's strange, but it's in simplest radical form. And that's the way they wanted it. So, all right, in example 2, suppose h is made smaller so the measure of angle P is 45, while bases and angles R and Q are unchanged. Okay, so if we don't change the angle R and Q, they both stay right angles, right? So there's R, there's Q, both are right angles. If we suppose h is made smaller, so h, this part right here, the height is going to shrink. It's going to stop maybe right around there because it's going to make it a 45-degree angle right there. Okay, I'm going to try my best to sketch this out. So luckily my iPad locks into place everything that I need. I'm going to have to fix that part though. Okay, let me get rid of those. Let's see if it works from this way. Doesn't want to lock on. Okay, you know what? Take that with a grain of salt. Let's say that that is a right angle. Yeah, let's say that's a right angle there. And that's a right angle there. That's still 5 meters. That's still 7 meters. That would mean that this would break apart here, and this would be 2 meters because this would have to be 5 meters. Well, if this is a 45, 45, 90, we're in a really good spot. Let me do this. Let me make those smaller. It appears that everything is the way it is. So here's R, here's Q, here's P and S. So P and S. Now what I did was I manipulated it, so I shrunk H down. Instead of this being a 30, 60, 90, this is going to come down to about here. This can be a 45, 45, 90. 5 stayed the same. It says that everything stays the same, that suppose H is made smaller so that the measure of angle P is 45. So it looks like it just shrunk vertically, okay, where R and Q are unchanged. So now I'm going to say that that's 45 degrees, that's 45 degrees, and that's 90. Now the way 45, 45, 90 works is these are the same length. So you don't really need to do much work for this. I already know that I can label them both 2 meters. So we have area equals B1 plus B2 over 2 times height. So area equals 5 plus 7. It's a total of 5 meters plus 7 meters over 2. We're not using 5 and 5. We're using that whole 7. Okay. Times height, which is 2. We're going to get area equals 12 meters, well, 2 meters. So 12 meters over 2 times 2 meters, which will be area equals 6 meters times 2 meters. So area equals 12 meters squared. And we are done. And so now we're going on to what I consider a little bit easier problems here. The area of a kite. Remember, area of a kite is 1/2, whoops, 1/2 diagonal 1 times diagonal 2. So area is going to be 1/2 diagonal 1. Let's call that 6. Diagonal 2. Let's call that 7. Because take a look. 3 plus 3 is 6. And 2 plus 5 is 7. So let me make this a little bit nicer. So 6 meters. And then I'll do purple. That's 7 meters. So it's going to be 1/2 6 meters times 7 meters. It's going to be 1/2 of 6, which is 3 meters, times 7 meters. So it's going to be 7 times 3, which is 21 meters squared. And we're done. And so now the next one, the area of a kite with diagonals that are 12 and 9. It gave us everything we need. So we're going to change everything to 12 inches and 9 inches. So area equals 1/2 D1 times D2. Area equals 1/2 12 inches times 9 inches. Half of 12 is 6 inches. So 6 times 9 is 54. It's 54 inches squared. Now, some of you are like, why aren't you, Mr. A, why aren't you distributing? This is just multiplication straight across. 0.5 times 12 times 9. It's not distributing because there's no addition or subtraction here. Just, do multiplication straight across. You can do half a 9 or half a 12 and then multiply that by the other term. Finding the area of a rhombus. Well, what's nice about a rhombus is that it has congruent parts as well. So if this is 12, oh, wait a minute. Okay, hold on. By the way, a kite that was labeled. Okay, this one, I apologize, does not have congruent parts. We got to be careful here. Well, it does. So this is 12, and so this is 12. What they didn't give me is the unknown here. I have no idea what that is. I have no idea what this is, but I can find it, and I know that they're equal to one another. So that is also important. But they gave me a right triangle, and what they want me to do is the Pythagorean theorem. So you either have to know your special right triangle, your Pythagorean triples, or you have to be able to do the Pythagorean theorem once for these problems. So 12 squared plus 12 squared plus x squared equals 15 squared. 144 plus x squared equals 225. So take away 144. So x squared equals, so 225 minus 144 is 81. So now find the square root of 81. So the square root of x squared is x. The square root of 81 is 9. So it's 9 meters. So this is 9 meters. Let me change these so you don't get confused by it looking like an equal sign. I'm just trying to say that they're congruent. There you go. So x is 9 meters. So now you have 9 and 9, which is 18. Whoops. So now what we have is area is 1/2 d1 times, let me try that again, d1 times d2. So area is 1/2 diagonal 1, which appears to be 12 and 12, which is 24 meters. And then it appears that it's 9 and 9, which is 18 meters. So looks like the area is 1/2. Oh, you know what? Half of 24 is 12 meters. Times 18 meters. So the area is 12 times 18, which is 216 meters squared. And we're done. In example 4, sorry, explain how you can use a Pythagorean triple to conclude that BE equals 9. Well, my Pythagorean triples, remember, the most basic one is 3, 4, 5. So 3 squared plus 4 squared equals 5 squared. Multiply these all by 3, and you get 9, 12, and 15. So that's the reason why you have 9, 12, and 15, because 9 has to exist if 12 and 15 do. 15 being the hypotenuse, 12 being the one of the other lengths of a side. Okay, and that's it. So you're already on to all of your practice problems. So make sure you do these and make sure you do the corresponding IXL assignments for credit. Good luck.